Okay, hello and welcome everyone to today's lunchtime webinar hosted by the British Hydrological Society. Today we're going to be hearing from the UKCEH, HydroSolutions and the Environment Agency on updated catchment descriptors for the FEH 2025 Statistical Method. From the BHS, we've got myself, Will Rust, and Kirsty Murphy, who is going to be keeping the show running, and we'll be fielding your questions to the speakers at the Q&A session after the presentation. Okay, so just some quick housekeeping. Please make sure that you keep your microphones muted and switch your videos off. This meeting is going to be recorded and will be uploaded to the BHS YouTube channel afterwards. And if you've got any questions and during the QA, please make sure you type these into the chat box in Zoom. It just helps us keep track of what questions have been asked and answered, and gives the speakers an opportunity to add follow-up information if they would like. Okay, I'm going to take this opportunity to give a bit of a plug for the British Hydrological Society. So we are a member-led society for all things hydrological. Our aim is to encourage interest, scholarship, and good practice in scientific and applied aspects of hydrology. Our sort of key activities, well, what we're often known for is events in person and virtual, such as this, where members of the scientific, people from industry and governance all come together to share ideas, share progress, and to build their networks. What people may not know is that we actually have travel grants and conference grants available to our members. So that's up to £800, depending on where you're going. We also provide studentship schemes in conjunction with JBA Trust of up to £3,000 towards master's fees. So if you're interested in either of those, have a look at our website where there's more details. If that wasn't enough, we also release a quarterly magazine called Circulation, which is an incredible pun, with news and information from the hydrological community. So for the very, very low price of £45 per year for an individual membership, if you are early career or retired, it's an astonishing £15 a year. So if you're interested, do sign up, have a look at our social media presences and our website for more information. So as I said, we are a member-led society, and we regularly rotate our national committee. In fact, very soon there will be opening nominations for new members of the committee to be elected as part of our AGM in September. So if you are interested in shaping the future of the British Hydrological Society and getting involved in the British hydrological community, then do keep an eye out for those calls for nominations. That's going to be circulating around the mail base and on our social media in the near future. And just a quick plug on upcoming BHS events. This is webinar 1 in our mini series of FEH webinars. Next Wednesday will be the follow-up, so do book your tickets for that on brown paper tickets if you haven't already. In the end of this month, we have our Peter Wolf Symposium, which is themed around hydrology in the community. That's actually free this year, but unfortunately registration is now closed. So we have these early career symposium, the Peter Wolf Symposium, every year. So do keep an eye. It's an excellent opportunity for early careers to grow their network and to learn about how hydrology is done in different parts of the UK and indeed internationally as well. In the middle of September, we have our AGM and an update on the flood hydrology roadmap. So this is the UK-wide incentive for forward planning and horizon scanning of what hydrology is going to be like in the future. So if you want to learn about new methods, new data sets, new ways of working in hydrology, do keep an eye out for those tickets for the AGM webinars, which are going to be out soon. And then finally, our our final thing on this list is a in-person conference held in conjunction with the Royal Meteorological Society in October this year, held in London. And this is going to be around forecasting flash floods. And this is going to be a really, really interesting interdisciplinary conference where us as hydrologists are going to learn how meteorologists do things and vice versa. So if you're interested in those, interested in any of these, have a look at our LinkedIn, have a look at our Blue Sky and our website for more details. So without further ado, I'm going to pass over to Adam now, who's going to introduce himself and the other speakers and lead our presentation today. Thanks, Adam.
Thanks, Will. Yeah, is the screen share switched over now?
Yeah, I'm just going to stop mine now and you should be able to grab it. There we go.
Yep. It's all working? Great. Yes, so good afternoon, everyone. I'm Adam Griffin from UKCEH, and today with Gianni and Steve, we're going to talk about the new catchment descriptors for the FEH 2025 statistical update. This is going to be work primarily from UKCEH, and Steve is here as part of the National Riverflow Archive. Representatives from Wallingford HydroSolutions, the Environment Agency, SEPA, NRW, and the Department for Infrastructure will be on the call. So if there's any specific questions to your to where you're working, they will be able to answer some questions today as well. So to put this in that kind of context and just for the purposes of completion, I think more than anything else, just a quick background on the flood estimation handbook methods. So the FEH methods date back a long time, so all the way back to the flood studies report, which were published in 1975. Since then, there was the flood estimation handbook, which was published, a 5-volume set of books that you can now get the PDFs for online, which came out in 1999, and that coincided with the release of the first version of WinFAP. And then since then, we've had smaller updates to various aspects of the flood estimation handbook. So in 2008, 2009, we had the previous big update to the FEH Statistical Method. And since then, we've had small updates, such as we did an update to BFA 19, which is a model change in 2019. And we've also had things like the introduction of the FEH Webservice and updates to WinFAP. And so here we can kind of see that history coming through there. So what is the FEH Statistical Method? Probably is a relevant point to go to. So the FEH Statistical Method is looking at flood frequency estimates. So what is the chance of a flow magnitude of a certain size occurring in any given year? So is it a 1 in 100 year flood? Is it a 1 in 2 year flood? And we could go into talking about whether that's changing over time, but that's not the focus of this particular talk. So if you've got, if at your gauging station, if you have a gauging station, and you have a lot of annual maximum data or peaks over threshold data, you can calculate these return periods directly. You can use the generalized logistic distribution, and you can calculate them straight from the distribution. Obviously, if you have got a short record or a poor record or no record, then you can't do that. And that's where the rest of the FEH statistical method comes in. So at the heart of it is an index flood method, which is split into 2 parts. We've got a local average and a kind of regional or kind of grouped growth curve. So ideally, hydrologically similar catchments should have similar shaped flood frequency curves alongside this local average, which moderates that. And so that local average, the index flood itself, is called the QMAD equation, which estimates the 1 in 2 year flood, which is the median of the annual maximum series. And this uses a range of catchment descriptors to substitute into a linear regression equation, which gives you an estimate for QMAD. There are spatial patterns in the errors in the QMAD model. And so the next step after using the QMAD equation is to apply what we call the donor transfer method, which corrects for this spatial model error by using the nearest good quality stations. Here, by good quality, we mean we're using the suitable for QMed tag, which is used by the NRFA, which is a reference to a certain level of hydrometric quality. In order to understand the rarer floods, we can also then apply a pooling method, which in some sense substitutes time with space, and rather than have a very long record, we have a number recorded a number of stations. So we use this regional flood frequency approach to make more use of more AMAX data. And in this case, we use hydrologically similar good quality catchments, which don't necessarily have to be nearby, but should be hydrologically similar. And in this case, this good quality is flagged as suitable for pooling in the NRFA data sets. Finally, the models that we've talked about so far assume a perfectly rural catchment, and to account for differences in runoff and permeability that we experience in urban areas, we have these scaling factors which we use to adjust certain parts of the model. And so there's an urban adjustment for the QMAD equation, and there's an urban adjustment for the growth curves, which come from the pooling approach. So what's this update all about? So what we've done is we have more data than ever before. We have more AMAX data, and we have new catchment descriptors available to us. And so out of the possible methods we have to hand, on top of the new catchment descriptors, which we're going to talk about today, we've updated the QMAD equation, updates to the donut transfer method, the pooling approach, and the urbanization adjustments. So all of these updates are methodologically similar. We've not done a massive overhaul on how you do QMAD estimation. What we have done is taken this new data and recalibrated all the models to best suit the new data that we have available to us. For using actual gauge data, we're still using the generalized logistic distribution using QMAD as the location parameter. Nothing else has changed there. As I mentioned at the top, there are representatives from all the devolved regulators, and they'll be on the call to answer some questions, but there will be some chance next week for them to present some recommendations on how you should be using our updates. So why bother updating the descriptors in the first place? Well, as I said, we have so much more data than ever before, and more of it is more open for the community to use. We've got nearly twice the amount of annual maximum data than we did since the last major update in 2008, 2009. We have access to continued updates to the UKCEH land cover maps. We have access and make use of the Met Office's HAD UK gridded data. And these new descriptors give us an opportunity to represent the present and to a lesser extent the future state of gauged and ungaged catchments across the UK. One of the thing process is for an ungaged catchment that you don't know the history of, the best estimate you have is what the catchment is in the current day. And we don't have a historical period to average measurements over. And if we're thinking of a forward-looking project, so we're looking to an engineering project which is thinking about the future rather than some sort of historical analysis looking at the past, thinking about the present is as close as we can get to having future ideas of the nature of the catchments. I should point out that none of the existing catchment descriptors are going away. They're all still going to be in the peak flow datasets, such as URBEX 1990 is still in the peak flow datasets. And they'll still be available and recommended for use in older projects and historical analysis. But we're going to be adding these new descriptors into the peak flow datasets and onto the FEH Webservice. So let's talk about the updated catchment descriptors. So what we have here, the ones we're updating today are SAR 9120, FILE 2015, URBEX 2015, BFEH 19 scaled. And I think at this point, I'll hand over to Johnny to talk through what they are and what the changes are.
Okay, thank you, Adam. So yes, there are 4 new updated catchment descriptors. They'll be released very soon. 3 of them are used in the QMED equation. 3 of them will be used for the pooling part of the statistical method, and 2 of them are used to do urban adjustments. This slide just shows like a summary. So there's SAR 9120, which is an update to SAR considering the period 1991 to 2020. There's FAL 2015, which is an update to FAL, so it's measuring flood attenuation due to reservoirs and lakes. URBEX 2015 is an update to URBEX 2000, so it's measuring urban extent. And then BFI Host 19 scaled is a small update to BFI Host 19, so it's measuring an estimate of base flow index based on the soil type. Next slide, please. So going through each of these in order, I'm going to start with SAR 9120. Much like SAR or SAR 6190, as it can be called, it's mean annual rainfall over the period 1991 to 2020. SAR 9120 is based on the Met Office HAD UK grid 30-year climate average version 1.3. It's not the values that you'll get from SAR 9120 are obviously going to be different from the values you get from SAR 6190 for some obvious and some less obvious reasons. So the main big first reason is that there's no temporal overlap between 61 to 90 and 91 to 20. You're measuring the rainfall over a completely different time period that doesn't overlap at all. Secondarily to time is gauges. So different gauges were used and open during the period of the first SAR versus the period of the new SAR. Some gauges were open for the whole time period. Some closed during the 1961 to 1990. Some may have opened partway through that period or opened after 1991. And so the gauges contributing to this descriptor, there's going to be differences in the data set. Some other reasons that are maybe less obvious are the infilling methods. So SAR 6190 was created about 30 years ago, whereas SAR 9120 is much newer. And the methods that the Met Office uses now to infill missing data in their rain gauges are not the same as the methods they used 30 years ago. And then finally, there's the gridding. So going from point values at the locations of rain gauges with inconsistent start and end dates to a regular grid based on data from a specific 30-year period. The methods the Met Office used to go from one to the other have changed in those 30 years. One thing that has to be noted about these two different time periods is that we've not done any attribution study to identify what changes have been specifically the result of climate change. There's other patterns that you might see there. So next slide, please. This slide compares the SAR 6190 descriptor and the SAR 9120 descriptor, where blue values show that SAR 9120 is higher, red values show that SAR over 1961 to 1990 is higher. So the general overall view is that between the old SAR and the new SAR, the new SAR is on average about 8% higher. The largest increases from old to new are in the Scottish lowlands. There's smaller positive increases in Wales and southwest England, which you can see is they're the more intense blues on the map. The largest change downwards from the old SAR to the new SAR is in the Scottish Highlands. And then there are some other small decreases that are scattered around, and these all depend on individual gauges recording lower totals over the more recent past than the more distant past. Part of the reason for some of the more extreme changes will be due to the fact that the old SAR and the new SAR are gridded. They're both gridded at 1 kilometer, but with different cell centers. So I had to reproject the old SAR in order to do this division. And some of the more extreme changes may have crept in because of that. However, one important follow-up point to having not attributed any of these changes to climate change is that whatever climate change allowances you would have used if you were using the old SAR, you need to use them again for the new SAR. So if you're doing the rainfall runoff method and have to apply a climate change allowance to the peak flow, for example, you still apply the same one with this new SAR compared to the old SAR. Next slide, please. The next descriptor I want to talk about is FAL 2015. FEH stands for flood attenuation from reservoirs and lakes. The difference with the FEH 2015 is it's based on a much newer data set, Land Cover Map 2015, and it's based on the vector data set of Land Cover Map. It's also used some information from Ordnance Survey in order to identify when a lake comes very close to a river, whether or not it's connected physically to the river. And also some processing has been done to remove things that look a bit like lakes, but are actually just wide segments of rivers. The way that you calculate FEH is unchanged. So it's the equation for it you can see on the right-hand side of the slide above these images of the Cotswolds Water Park. So it's essentially, you take the surface area of the reservoir or lake, you compare it to the upstream subcatchment area. That's one ratio. And then the other ratio is the upstream subcatchment area against the catchment area of the entire catchment that you want FEH for. And it's a product of these terms. So there are some major reasons for differences between the existing FEH and FEH 2015. One of the big ones of this is that even though the original FEH was calculated in 1999, it does not contain some major reservoirs like Rodeford Lake or Carsington Water. Another reason is that the new vector data set means that it's much easier and more accurate to identify which lakes are connected to rivers and which are not. That's the online and offline status. Figures A and B show you the difference between how Cotswold Water Park is represented in the existing FEH versus FEH 2015. And then, of course, because it's all vector data sets, you can get a much more accurate estimate of the lake or reservoir area because it's not restricted to being made out of squares. Next slide, please. So there are some differences between FEH and FEH 2015. Some of the major differences happen along the River Trent, where the Land Cover Map 2015 has some sand and gravel extraction lakes. That explains the downward arrows you can see along the path of the Trent. We should say in this map that blue downward arrows mean that FEH is a lower number, which means there's more flood attenuation, whereas the upward pointing arrows mean FEH is a higher number, so there's less attenuation. You can see where some of these increases are where FEH has resolved, or the new index has resolved the water body as offline, so not contributing to flow attenuation. Whereas before, with the less precise data set, the water bodies were assumed to be online. One point about FEH 2015 is just like FEH, it still doesn't include storage reservoirs that are usually dry. Although I will point out that the descriptor FPX includes areas that are inundated under the 100-year flood that are normally dry. So it's possible that if you're interested in these usually dry storage reservoirs, FPX might contain them as a descriptor. Next slide. So the third descriptor is Urbex 2015. This is a measure of urbanization that's based on Land Cover Map 2015. It uses the same calculation method as Urbex 1990 and Urbex 2000 if you account for the fact that Land Cover Map 2015 only includes the urban and suburban classes, whereas Land Cover Map 2000 also included inland bare ground. So essentially, it's the fraction of the catchment that is classed as urban plus half of the fraction of the catchment that's classed as suburban in Land Cover Map 2015 to give you the Urbex 2015 index. Urbex 2015, if you're doing an analysis for the present day, you should make some attempt to try to scale it to present day levels if you know, for example, that there has been an increase in urban development in your catchment since 2015. The images on the right show you the difference between Land Cover Map 2000 and Land Cover Map 2015 for an area in northwest London. This particular case is showing you where Urbex 2015 has decreased since Urbex 2000. And you can see there it's because more of the land in that catchment has been resolved as suburban rather than urban. Next slide, please. So this map on the right shows you changes from Urbex 2000 to Urbex 2015 for all the NRFA catchments. You can see around London there are a few down arrows, and the example I showed you on the last slide is the reason for that. But you can also see the overwhelming majority of catchments have small up arrows indicating a slight increase in urbanisation. And then some catchments around the edge of major cities have larger up arrows showing where the urban area has expanded. This bar chart at the bottom shows how many catchments belong to each urbex category. So left to right, essentially rural, slightly urbanized, moderately urbanized, very urbanized, extremely urbanized, going from 1990 to 2015. That also shows a general increase from 1990 to 2000, and again 2000 to 2015. Next slide. Okay, so BFI host 19 scaled is the fourth descriptor we updated. This is a way of estimating base flow index using the host soil classes. This is a smaller update than the others. This was essentially done just to reduce the effects of double counting water bodies. It reduces the correlation between BFI host and FAL 2015, and it also, use of it slightly increases the fit of the QMed equation and slightly reduces the uncertainty in the equation. So the way this is calculated is within your catchment, you'll take the fractional coverages of all the different host classes plus water. If there is any water, you remove that. The remaining classes don't add up to 100%. You scale all the remaining classes upwards equally till they reach 100%. And then you perform the same calculation that you would to calculate BFI host 19. So using the coefficients in the table shown here and the logit sum transformation shown in the equation above. This means that if there's no water body in your catchment, BFI host 19 and BFI host 19 scaled should be equal. Next slide, please. So yes, you can see on this plot of BFI host 19 against BFI host 19 scaled that most values are very similar and many of them are exactly the same. And these are catchments that don't have water bodies. BFI host 19 scaled is smaller than BFI host 19 in catchments that have water bodies. It's not a perfect correlation with FAL because BFI host 19 scale also removes the effect of water bodies that are offline as well as online. There are two catchments where BFI host 19 scaled is a higher number than BFI host 19, which shouldn't be possible. But the reason for this is that in the 6 years since BFI host 19 was calculated, these two catchments have had their outlet points corrected, which has changed the shape of the catchment and its area, and has in these two cases incorporated land that has slightly more permeable soils. Next slide, please.
So here I'll jump back in. Thanks, Jenny. That was really useful and informative. And we're going to talk about, now we've got these catchment descriptors, what are we going to do with them? What do we recommend people actually use them for? So in the first and foremost, we're going to be using them in the new statistical updates that we'll talk about next week. But I think we should, this is a really good time to remind people about the FEH kind of local thought process, which is if you're considering using the new descriptors, always think about what you know about your catchment locally. So if you look at the new descriptors and a value looks odd, see if local knowledge gives you a better value. Check nearby catchments, check historical records. If you have the resources, maybe you need to take new measurements to see if you can get improvement on those measurements. Additionally, although these catchment descriptors kind of look nice and neat, there are some unique properties of catchments that they don't cover. So things like groundwater transfers can lead to an incorrect, lead to the kind of area as defined by the NRFA dataset or the FEH methods to not accurately describe the true catchment area because of these transfer properties. The QMed equation and the donor transfer that we'll discuss more next week are not systematically biased to catchment descriptors. So they don't work any better in any particular type of catchment, but they do both rely on catchment descriptors representing the catchment accurately. What this means in kind of basic terms is if your catchment descriptors aren't very good, then your cumulative equation estimates aren't very good. So how should we be using the new descriptors? The new descriptors are designed to be used with the new 2025 FEH Statistical Method, not designed to be used with earlier statistical methods. And likewise, the new method isn't designed to be used with the old descriptors. Additionally, the new descriptors aren't designed to be used with RefH2 or any of those similar types of models. They're currently being that particular model is being recalibrated at the moment. And when there's more information, I'm sure you'll hear about it. If you have legacy projects that have been going on before, or you need to a historical project, or you need to reproduce some projects that have been done in the past, don't change the descriptors you're already using, especially if you're using the previous models. What the idea is for these new descriptors is to use them for forward-looking projects, so things that are planning for the future. And if you're thinking about an ungauged catchment, these new descriptors are exactly the kind of things you should be using. And as a slight repeat, but as mentioned before, the URBEX 2015 is, as the name suggests, an estimate for the urbanization in 2015. And as one of the most rapidly changing catchment descriptors, that it is encouraged that one should try and make an attempt to update the urban extent values forward to the present day where possible. At this point, I'm going to hand over to Steve Turner from the National Riverflow Archive team to talk a little bit about what's going to come in the dataset.
Great, thanks Adam and Gianni. It's really great to hear about the new catchment descriptors and all the improvements that have been developed for those. So many of you will be aware that to get those catchment descriptors for gauged catchments, many of you will get them via the Peak Flow dataset, which is published by the National Riverflow Archive once a year. The next version 14, we're busily working on as we speak. We're hoping to get that out and published in late August. So perhaps I'll put in the chat in a little while. There's the NRFA mailing list. If you'd like to sign up to that to be first to know when it's published, that would be great. Version 14 then will include the annual update for all active peak flow stations for the water year 2023 to 2024. And as well as adding that additional year of data, we've carried on with our series of period record reviews where we've taken a handful of sites every year and looked at that full record, including the pre-digital record as well. And in version 14, that's been going on for 88 stations. And really, the NRFA has been publishing this peak flow dataset for almost 10 years now, and we're getting to the stage where almost every station has been through that period record review. So hopefully, yeah, lots of improved data and records there. And then, of course, yeah, we'll include these new catchment descriptors, which we've just heard about. They'll be available in the XML file that comes out with the dataset. As was previously mentioned, none of the old catchment descriptors are going to disappear or anything like that. There'll just be a few more rows in the XML file, which includes these new descriptors that we've just heard about. And I guess lastly, just like to mention, hopefully many of you might have noticed that earlier in the year, we had a relaunch of the NRFA website with a new design. But as well as that, there were some improvements to the search pages and the search capabilities, some of the plotting, but also perhaps relevant to this audience, you might have noticed at the bottom of every station page, there's a little link that says email us about this station. So when you're working on any of these gauging stations, and if you spot something like during your study that it would be useful to let us know about, we'd really encourage you to get in contact and let us know about those things you might spot, and we can then take that up with the measuring authority in that region, and if we can make any improvements, it's just a great way to feedback to us to sort of keep improving. But I think that's all to say from the NRFA point of view, so I hand back over to Adam.
Yeah, thanks, Steve. Yeah, looking forward to getting the NRFA Peak Flow dataset coming out. Just as a mention on this point, like last year, the FEH team will also put out a small note within the release notes and a larger one on the website about how the new NRFA dataset impacts flood estimation methods. So this year, it's going to also talk about how the new methods are impacting datasets, but the release notes will also describe how just the new addition of a new water year might impact your gauged estimates as well. So yeah, that's kind of where we've got to so far, kind of leaving us somewhat in the middle of the story, where we've given you the data to use, but not the tools to use them on. So next week, we're going to be looking at using the data. So we'll talk about the QMAD equation, the donor transfer, the pooling updates, and the urban adjustments. And as a kind of general note that UKCEH is a scientific organization. We don't directly enforce any sort of regulations. You should always follow your local or national guidance and regulations when undertaking any sort of project. And as I said before, local knowledge should always supplement national scale statistics. All the models and all the new data is based on as the best available on a national scale on average, without any understanding of local data quality or quirks in the data. So if you don't know anything about your catchment, the best starting point is these new catchment descriptors and new methods we're going to talk about next week. If you have local data and you have local knowledge, then you can supplement that and improve your estimates of flood frequency in your project. So yeah, this has been a large piece of work, and I would just like to thank all the measuring authorities and the NRFA and Wallingford HydroSolutions and everyone who's contributed to the work. And as well mentioned at the top of the webinar, tickets are still available for the next week. So if you want to see how the methods are used, you can still get tickets for that. So I think at this point, there's a link to our webpage. The full report will be up in the next day or two. They're just percolating through our webpage review system. And you'll be able to check out the full report, which discusses all of these in a bit more detail. And if you've got any questions that don't get answered today, feel free to email me or Gianni at CH to answer any other questions you have. So yeah, I think at this point, we'll hand over to those questions. How do you want to do this? Shall I just go through things, or Kirsty or Will, are you going to?
Hi, yeah. First of all, really great presentation. Really enjoyed that, and really important changes, it feels like, as well. Definitely looking forward to next week's webinar as well. So yeah, just to reiterate, it's the same time next week. That you can scan that QR code, have a look at the Brown Paper Ticket website, and sign up for next week as well. I would encourage everyone to do that. In terms of questions, what I'll do is I'll read out the questions to you, and then put it to then whoever would like to respond, then feel free. So yeah, we've got a few questions that have come in. The first question was there a specific reason why FPX wasn't updated along with these updates?
So I think there wasn't, I think we identified the catchment descriptors we could most improve with the new data available. FPX being linked somewhat to things like the DTM and that kind of continuous evolution of that was part of the reason FPX wasn't updated. Obviously, it's kind of next analyst in this sort of thing. So there's a possibility that we will revisit FBX and go forwards, looking at that in the future.
Cool, brilliant. Next question. So these climate change allowances are uplifted compared to a baseline date, which is, well, I think 1990. Oh, sorry, it has moved around. So Claire Waller has just responded, but I'll continue with the with the question anyway. So if rainfall baseline, so if our rainfall baseline is now later, shouldn't the uplifts be due to the new baseline? I will say Claire has responded with a comment. I won't read it. I will let people read themselves. But if anyone, any of the speakers have a response to that.
I'm just scanning through it now. Yeah, I think I agree with Claire's point that until there's been like an actual change attribution study, then we can't split up all the different changes into what's climate change, what's land use change, what's natural variability. And yes, SARA is an average rainfall, not an extreme rainfall. So yes, I agree with all these points. And yeah, I think, and the climate change allowances at the end are not a thing that the UKCEH is specifically recommending, as in the Environment Agency and the CEPA and the other regulators are the people determining these climate change allowances. So keep your ears open for what they have to say.
Right, perfect. Now, definitely understand that. Definitely understand that. That was well explained. So I think might have already touched on this, but there's a question here from Fiona. Are there any plans to update any of the DTM and any catchment descriptors derived from it?
So a few of the catchment descriptors have been so a few of the catchment descriptors have changed due to updates to the DTM and how we interact with it. So as was mentioned on the BFI host 19 scaled, there was those two catchments which had been shifted due to a correction in finding the outlet point. I don't know whether there's more on any of the other descriptors. Gianni, do you have any science plans to look at some of the other descriptors such as DPL bar and things like that?
All of those are very dependent on the DTM.
Yeah. So interestingly, the choice of DTM at this point does make a notable difference. So depending how well or your model of the train is, it might make a big difference. So that's a bigger task than just updating the DTM.
Okay, brilliant. Okay, next question we have here from Michael. Can you advise when the descriptors will be updated on the FEH web service?
Yeah, Tracy, do you want to take this one if you're still there?
Yes, all I can say is and I'll answer, I think there's might be a question about WinFAP a bit further down as well. So I'll say, so there has been a lot of liaison between UKCEH, the NRFA, the FEH Webservice, and Wallingford HydroSolutions. So all of these should pretty much coincide. So the NRFA will be releasing the peak flow dataset first, and then probably a week, maybe 2 weeks later maximum, a new WinFAP will be released, and the FEH web service will be also able to download those new data. So we've tried really hard to make it so that they all sort of coincide together, notwithstanding the fact that it's summer and the summer holidays.
Brilliant. Where are we? Okay, so we've got a question from, yeah, that's right, Ashling. So 2 questions relating to the Northern Ireland border catchments. Is SAR estimated using rainfall gauge data from Ireland and Northern Ireland? And does FAL from cross-border catchments include lakes in the Republic of Ireland?
Okay, so FAL cross-border catchments, they include Republic of Ireland lakes derived from Corrine Land Cover 2018. And then for the SAR for cross-border catchments, the version of the HAD UK grid that we have includes a buffer zone around not just the coast of the of Britain, but also around the shape of the Republic of Ireland. So it extends roughly 20 kilometers past the border. That covers nearly all the cross-border catchments. And then for the tiny bits of cross-border catchment that are not covered, we used 1991 to 2020 data from CEH Gear, which uses the same underlying data sets as the HAD UK grid, but extends to cover the whole of the FEH Webservice DTM. So given that's such a small part of the cross-border catchments, by the time you're able to click on a point that's within Northern Ireland, the bits that are not derived from HAD UK grid are going to be making up such a small part of any catchment you might be able to click on that it's not going to have a big effect at all.
Okay, brilliant. Thanks for that. So we have a question from Richard here, which has been answered, but I will read it through just so everyone is aware. A question about the grey area between legacy and new projects. If flood modelling has been completed for an FRA to support a planning application that has not yet been submitted, is there a period over which the old FEH data and methods can be relied upon? Otherwise, clients will be challenging on the implications of increasing flood extents. Now, we had a response from the Environment Agency and RW to say that that's going to be addressed next week. So, so all the more reason to sign up to next week's webinar. Yeah, brilliant. So, Steve, you've put in an NRFA newsletter link. Perfect. We're still good for time. So is everyone good for continuing with the questions for now? We're still good for time?
Yep.
Yeah.
Perfect. So a question here, how can peak flows between RefH2 and stats be compared if we can't use the new CD for RefH2 method?
So I'll just,
yeah, go on,
shall I
Tracy.
answer that? So, I mean, I guess I'll just say that, to be honest, they're just different methods for estimating for our best estimate of the peak flows. So RefH2 is calibrated using the old catchment descriptors. So it will give you a best estimate using the design peak flows for that. And we can still compare it with the statistical method that has just been calibrated using slightly different descriptors. As Adam said, slightly sort of medium term, we would like to go back and look at RefH2 and recalibrate it. But I think just recalibrating it to these new statistics without doing additional work to sort of maybe try and improve some aspects of it would seem like a not an efficient use of our time. So I think we want to look at it in a bit more detail rather than just recalibrating the parameters to improve the parameters for the new descriptors. Adam, did you want to add anything else to
that? No, I think you can pretty much caught everything there. Just with my stats add-on, I think I would emphasize the first bit. There are two different approaches to comparing what is quite a difficult thing to estimate and kind of model.
Yeah.
Thank you very much. We have another question. Again, this might be for you, Tracy. When will the new descriptors be incorporated into new versions of WinFAP?
Yes, so I did answer this slightly before when I was talking about the FEH Webservice. So basically early September, there'll be a new release. And there's going to be a couple of slides on it next week, just so that people are aware of how it will look differently and how it's going to work, so they can think about how it works into their workflow and how old and new methods can be still used, essentially.
Brilliant, thank you. Not so much a question, but maybe a point for discussion. Catchment areas have been changed in some places. In that case, it may be difficult to compare with previous versions. Any thoughts on that?
So it's true that some of the catchment areas might have changed slightly due to improved ways that the things have the catchments have been snapped, the poor points have been snapped to the grid. So in most cases here, the data sets we're able to use will either be visible on the FEH Webservice. So we're hoping to add a visual layer to the FEH Webservice, which includes what lakes have been included in the file 2015 calculation. And for other descriptors, you can download your own version of the land cover map 2015 or the HAD UK average rainfall grids, and you can do your own calculations that way. The idea is these methods should stand on their own. the point of this exercise was to have them stand on their own using the current catchment areas as they've been outlined. The catchment area realignment wasn't done as part of this work specifically. It's an ongoing kind of period of record type exercise that's taken by the regulators and NRFA.
Brilliant. Okay, so we have a question from Aisling here that has been answered, but I will just say it out to everyone. Will there be local guidance coming from an EA, CPA, DFL on timings to use the new descriptors method? So we've had responses on that. Again, that's going to be covered in next week's webinar. And then for now, one final question. Gianni mentioned accounting for urban development post 2015 when using the new URBEX 2015. One way of doing this is by using the UEF model. When URBEX 2000 was released, the UEF model was rescaled, so UEF for the year 2000 was 1. Will that be done again for URBEX 2015?
Okay, so yes, there is a new UEF that recenters URBEX 2015 as a value of 1, but that's a national average. And as we saw on the slide of changes from 2000 to 2015, it really depends where you are in the country about whether or not your particular catchment will have had a growth that's similar to the national average or not. If it's around the edge of a major city, it's probably grown more than the average. If it's in the middle of the countryside, probably less. So what we'd recommend now, given like the quantities and easy availability of digital data, is to have a look at your specific catchment to see what changes have occurred in your specific catchment since 2015, and to derive a new URBEX that's using the similar methodology to URBEX 2015, but as a bespoke case for each catchment whenever possible.
Yeah, so this is just reinforcing the local data. These methods will work if you have no extra information about a catchment, but if you have the resources to do so, always double check these kind of catchment descriptors and see if you can do better for your specific catchment.
I was just going to add then Gianni used the URBEX 2015 based on the LCM 2015 dataset, but the LCM should be being updated on a much more regular basis. So it will be much easier for people to directly update those URBEX values, which in the past they wouldn't have been able to do because the LCM methods and data sets, etc., were changing over time. It was actually quite difficult to update the URBEX 2000 index. But because these data sets are becoming more regularly available, it is possible to do that. We are adding in the URBEX 2015 LCM spatial layer into the FEH Webservice, so you'll be able to see exactly what's included in your model. Then you'll have the map data underneath, so it will be quite easy for you to spot whether it's going to be a problem in your catchment or not. So you don't have to do this every case. You'll be able to have a look at your catchment and say, okay, do I need to update it in my catchment or not? We're also going to give another couple of options in WinFAP for updating those URBEX values as well, using slightly easier to use and quicker data sets as well. So there should be a number of different methods by which you can update it.
Yeah, the main reason we chose to use URBEX 2015, use line cover map 2015, is because that was the most recent version, which had like a quite high level, detailed quality control process applied to it. So it's the one we felt most appropriate for these kind of formal national scale applications.
Yes. So if you're using a newer URBEX, a newer LCM than 2015 as a source for creating a newer URBEX descriptor, just bear in mind that newer LCMs have had less comprehensive manual quality controls, so you will need to do that yourself.
On the plus side, there's a lot of automated QC that goes into the LCMs, like they do a hell of a lot of work, but just note, yeah, there's not been the resources to do that kind of manual high detail QC on more recent releases.
Yes. Yeah.
Brilliant. Thanks everyone for that. That was the last question. So the speakers have said that they are more than happy to be contacted if there's any follow-up questions. And yes, that's it from us. Are there any more points from any of the speakers that we'd like to make?
No, I'd just like to thank the British Hydrological Society for helping us put this talk on, and hopefully for next week as well. And thanks to Gianni and Steve for talking, and everyone else for all their work they put in.
Brilliant. Thank you to the speakers. Thanks everyone for joining. And yes, we look forward to seeing you next week.
Cheers all. Thank you.
Thanks.